problem 31. It's a typical example given to Calc 2 students, typically when you introduce trigonometric substitution for integrals. Right, so if I were giving this to a student to do, I definitely would give a hint to it, right? And I would certainly, again, if you look at my notes too for Calc 2, the hint I give them to do this particular problem is to multiply the top and the bottom by a unitizing factor. And that unitizing factor is secant x plus tan x over secant x plus tan x. So that's really just one, it's a unit. And if you multiply that out, what are you going to get? Let's write that down for you. You're going to get secant squared x plus secant x tan x, and multiply the top out, right? What do you get in bottom? Just secant x plus tan x. And there's a dx here. So I'd make that recommendation. Again, if you looked at my Calc 2 notes, this is one of the recommendations I would make. The next recommendation I'd make is you make a u substitution now. And I'd probably tell the students, at least I know I do in my notes, what the u substitution is. And it's going to be this over here. So 2 big hints. What's du going to be? Well, the derivative of secant tan, and the derivative of tangent, secant squared, and then dx. What's the point of that? Well, if you look at it, you should notice that this over here is just du, and this is u. So what are you left off with? You're left off with this. 1 over u du, which is kind of simple, just natural log absolute value of u plus some constant of integration. What are you going to do now? Go back to land of x's. So natural log absolute value secant x plus tan x, that's what our u is, plus c. Then what do you do? Look at the key and verify that what we're saying is what's written in the key, by the way. All right? So I just want to, we're kind of like moving towards something that typically not covered, at least at the school I teach. We don't cover some techniques of integration. The big ones, and I want to say what the big ones are: recognition, u substitution, integration by parts, partial fractions, trigonometric substitutions. These are kind of typical, all right? So there's another way forward, though, all right? And I want to briefly talk about that, and it's a Weierstrass method, all right? And again, we'll derive it, but right now I want to point out what the Weierstrass method is. It's basically using a half-angle formula to simplify things, all right? So let's just accept it, all right? So it says over here that we're going to be using these things over here, that this is t, that this is going to be sine, this is going to be cosine, and this will be the differential. So let's go back and rewrite it. And it actually makes it a remarkably easy problem to deal with when you do that. So let's write down the original problem. The original problem is secant. And again, we're just introducing this. The very next problem will actually derive it for you. So the secant of x dx, well, this is really going to be 1 over cosine of x dx. What I'm going to do, make a substitution. And again, this is deceptively tricky, by the way. Let's write it down. So it's really 1 over cosine. And so 1 over cosine is just this guy right over here. And it's just a reciprocal of it. So it's going to get 1 plus t squared over 1 minus t squared. So I just did the cosine. That's all I've done. So all I've done is this over here. Now let's put the dx down now. What's the dx going to be? Well, it's going to be 2 over 1 plus t squared dt. Well, this disappears. And what are you left off with? 2, 1 minus t squared, which is 1 plus t, 1 minus t, dt. I'm going to use partial fractions, typical, right? 2. I'm going to put 1 plus t here. Let's put t plus 1 down, looks better. No, actually, I'm not going to do that. We'll talk about why in a second, by the way. 1 plus t, I'll put an a here, plus b over 1 minus t dt. Let's figure it out, and I'll write this down. I will be erasing it, though. So 1 plus t, 1 minus t is equal to a over 1 plus t plus b over 1 minus t. Clear the fraction, you get 1, a, 1 minus t, plus b, 1 plus t. Pick some easy values for t. I'd say t is 1's an easy value. What do you get here? 1 equals 2b, which means b is 1/2. Let me get my eraser out. And, sorry about that, I have to get my eraser out. The b is 1/2. All right, let's get the a. All right, how do we do that? I'm going to pick t to be -1 now. And what do you get there? Again, we're plugging it in here if you're curious. Let's see, we're going to get 1 equals 2a. So a is 1/2. Get my eraser out. Put that down. I'm sorry, it's over here. I'm gonna erase that too, by the way, but 1/2 over here. Sorry about that. Shrink that down. And I'm gonna erase this over here. Both of those are 1/2. I'm gonna get my eraser out and get rid of this, I'm not gonna say nonsense, but some people can do it in their head. I noticed that when other teachers do it at the whiteboard on YouTube, they're doing this stuff in their head. I find it kind of remarkable, but they can do it. They can do it, Good for them. I'm going to simplify this, and let's write this down. So I'm going to write it as 1 over 1 plus t plus 1 over 1 minus t dt. I want to rewrite, this to make a little bit more familiar for me. And again, it may not be familiar to you, but I'm going to say t plus 1 minus 1 over t minus 1. I can integrate this guy. What do you get? Natural log, absolute value, t plus 1, minus the natural log, absolute value, t minus 1. By the way, I keep forgetting my star, plus c star. Got to go back to the t's, but before I do that, I'm going to write this as 1 natural log. All right, let me get the eraser out again. It looked like I was writing limit down, but I'm writing natural log ln. Absolute value, t plus 1 over t minus 1 plus c. All right? So someone says, am I done? No, you're not done. We started with an x problem, and now we got a t problem. I got to plug this in. And what's t? It's tangent of x over 2. I'll write that down for you. By the way, there's some nice identities for the half angle formulas. You can actually manipulate this thing to get to look exactly like we want it to look like. Like I would say for the most part, this is something we really wouldn't have written down in Calc 2. But if you're using the Weiser-Strauss, that's okay to write that down. It is equivalent. All right, let's look at the key and see if we got that. I'm looking at this over here. Oh, made a mistake. I just saw it. I'll correct my errors as I look at them. And we're good to go. I did it again. I know I do that a lot. I think it's just from exhaustion, by the way. I do a lot of problems. And this works out pretty nicely. All right? Again, you can manipulate these guys to make sure they're equivalent, and they are. All right? Thank you.